Hey class, in today's lesson we're going to talk about verifying trigonometric identities, which is found in section 5.2. Our objective is to verify trigonometric identities. So just some guidelines to verifying trigonometric identities. The first thing that you want to do is work with one side of the equation at a time. It's often better to work with the more complicated side first. After that, look for opportunities to factor an expression, add fractions, square a binomial, or create a monomial denominator. After that, look for opportunities to use the fundamental identities. Note which functions are in the final expression that you want. Sines and cosines pair up well, as do secants and tangents, as do cosecants and cotangents. Also, then if the preceding guidelines do not help, try converting all the terms into sine and cosines, and at the end of the day, just try something. Even making an attempt that leads to a dead end can give you some insight on how to take your next step. So in example 1, we are asked to verify the trig identity. Again, with verifying, you simply simplify one side to prove that it equals the other side. So in this case, we want to simplify the left-hand side to prove that it equals the right-hand side. Well, I hope that you guys recognize, but within the numerator, you actually already have a Pythagorean identity already in its form. Because secant squared theta minus 1 is tangent squared theta. Again, the better off you are at recognizing your Pythagorean identities, the better off you'll be. So that leaves me with tangent squared theta divided by secant squared theta, and it's currently still set to equal sine squared theta. However, that's not what it is right now, so let's continue to simplify. So I can break apart the numerator, or this fraction, into two fractions to become tangent squared theta times 1 over secant squared theta. Tangent squared theta is sine squared theta over cosine squared theta times secant by itself is actually 1 over cosine, but I could also just say, well, let me just write it, 1 over cosine squared theta. And I know dividing by a fraction essentially multiplies by the reciprocal. So that becomes sine squared theta over cosine squared theta times cosine squared theta. Okay, cosine squared theta cancels, and so we're left with sine squared theta equal to what we were trying to prove in the first place, which is sine squared theta. Again, notice I only dealt with one side of our equation at a time. I did not try and do both sides. I did not solve by like adding on one side, adding to the other, or multiplying on one side to multiply by the other. That's a common mistake that as a first step in this problem, most people would try to multiply both sides by secant squared theta. Do not do that, because that's not verifying, that is solving. All right, let's look at the next example. All right, in example 2, again, we're asked to verify. So we have 1 over 1 minus sine theta plus 1 over 1 plus sine, I said theta, it's really alpha, equals 2 secant squared alpha, okay? In this case, because what I see in the denominator makes me feel like I should probably try to get my denominators the same, that's what I'm going to do. So I'm going to multiply each fraction by the denominator of the other. So this becomes 1 plus sine alpha over 1 plus sine alpha. And the other one becomes 1 minus sine alpha over 1 minus sine alpha. Okay, so in the grand scheme of things, our denominator becomes 1 plus sine theta, or alpha, sorry, I keep saying theta, times 1 minus sine alpha. That's for both the denominators. Okay, and the numerator of the first, in other words, I'm talking about this numerator here. If I multiply it times 1, that gives me 1 plus sine x. If I talk about this numerator here, and it's still addition, and I distribute the 1, that gives me plus 1 minus sine x. Okay, from there, the sine x's will cancel, and that's going to leave me with 2 over, and if I did the box for the denominator, right, did the box. I think we've already done this maybe on a last lesson, this lesson, not really sure. Everything runs together after a while. But that gives me 1 negative sine alpha. This is positive sine alpha. This would be negative sine squared alpha. That'll leave me with 1 minus sine squared alpha for my denominator. However, we already know that this denominator is the same thing as cosine squared x. So it leaves you here with 2 over cosine squared x. Shouldn't say x, talking about alpha. But again, we know that we can split that fraction up, right? So that can really become 2 over 1 times 1 over cosine squared x. And cosine, I should say x, oh my goodness, I've done that like 5 times in this slide. Anyways, cosine squared alpha, 1 over cosine squared alpha is secant. So we have 2 secant squared alpha equal to what we were trying to prove in the first place, which is 2 secant squared alpha. All right, we are done with example 2. Let's take a look at the next one. All right, and try number 2. Again, we're trying to verify. In this case, what I recognize right off is that right here we have a Pythagorean identity. Again, knowing those heavy hitters, knowing those Pythagorean identities will really help you out with your recognition skills. So tangent squared x plus 1 is secant squared x. And then I also recognize that this one here is very close to a Pythagorean identity. And I know it's close because I know that sine squared x plus cosine squared x equals 1. And I want this to equal sine squared x. However, if I were to subtract cosine squared x on both sides, I essentially get that sine squared x equals 1 minus cosine squared x. So thinking about this in rewritten form, this is really negative 1 plus cosine squared x. And that's not the same thing as 1 minus cosine squared x. So to get them to be the same, I can essentially divide both sides by negative 1. So then negative sine x then is the same thing as what I see, which is negative 1 plus cosine squared x. Okay, so now I can rewrite this, and this becomes negative sine x. And over here, like I mentioned before, this is secant squared x. And then from there, it just becomes a rewriting thing. So secant is the same thing as 1 over cosine squared. And I apologize, I dropped the squared for some reason. And this is times negative sine squared x. Putting them together, that will become negative sine squared x over cosine squared x. And we know that that is the same thing as negative tangent squared x, which is, again, what I was trying to prove with negative tangent squared x. Take a look at our next problem. In example 7, we're converting to sines and cosines. Like I mentioned before, sometimes when you really just can't do anything else, the common denominator of all this can simply just be trying to write everything in terms of sine and cosine. So let's try that with what we have. We are going to try to prove that the left-hand side equals the right-hand side rather than the right-hand side equaling the left. You can definitely try to prove the right equals the left, but sometimes it's just easier to go left to right or whatever seems simpler to you. And for me, the left side seems simpler. So tangent is the same thing as sine x over cosine x. And cotangent x is the same thing as cosine x over sine x. Since these are two fractions that I'm trying to add together, I'm going to multiply each by the denominator of the other. So this will become sine x over sine x. This will become cosine x over cosine x. All right, now that they have the same denominator, which is sine x, cosine x, this numerator of the first one becomes sine squared x. The numerator of the second one becomes cosine squared x. And again, we already know that sine squared x plus cosine squared x is 1. So now this is 1 over sine x, cosine x. As we've looked and dealt with fractions today, you should know that you can split your fraction. So this can be 1 over sine x times 1 over cosine x. And at this point, we're finally at the end where we just rewrite. So 1 over sine is cosecant x. And 1 over cosine is secant x. And just for the fact that Ms. Richardson is a little particular about this, go ahead and flip-flop them to match the answer that we want. So now we have that secant x times cosecant x, oh my goodness, cosecant x equals what we were trying to prove, which is secant x cosecant x. Take a look at our last problem. Alrighty, and try number 3 says to verify that secant x plus tangent x equals cosine x over 1 minus sine x. In this case, I'm actually going to start with the right-hand side. Dealing with the fraction sometimes right away is a lot easier than having to deal with it on the back end. So again, with this, what I want to deal with is trying to get that 1 minus sine x out of the denominator. So I'm going to multiply it by the conjugate, which is 1 plus sine x over 1 plus sine x. We've dealt with multiplying that denominator before, so that's going to give us, as that numerator distributes, by the way, that's going to give us cosine x plus cosine x sine x over, our denominator will be 1 minus sine squared x. 1 minus sine squared x, again, that's a Pythagorean identity, and that's going to give us cosine squared x. In the numerator, we have cosine x plus cosine x sine x. All right. I see something I can do in the numerator. I can split those two numerators over cosine squared x. So this becomes cosine x over cosine squared x plus cosine x sine x over cosine x. All right, cosine over cosine squared, that means one of the powers is going to cancel, right? So that leaves me 1 over cosine x plus, with this fraction here, the second fraction, I can split that into 2. And that becomes cosine x over cosine x times sine x over cosine x. Nope, sorry. I shouldn't have even done that. Let me back up just a bit, sorry. What I can actually do is just cancel out the cosines. Let's not make this harder than it is. Okay, so then I'm left with sine x. All right, so 1 over cosine x plus sine x, and oh my gosh, I got rid of a squared. Sorry, that was cosine squared. That's, yep. And so I'm really left with sine x over, there's still 1 cosine x left in the denominator. All right, now we're finally at the end where 1 over cosine is secant x plus sine x over cosine x is tangent x. And we just proved what we were trying to prove in the beginning, which is that secant x plus tan x equals itself. All right, guys, we are done. If you have any questions, again, please be sure to come see me for tutoring.